Hello everyone, welcome to my channel. In this session we are going to learn the concepts related to model selection in machine learning. So we are going to learn two important techniques applied during model selection process known as KFold validation, which will allow you to measure the most relevant way in the performance of each of your future machine learning models. Then we'll also learn the grid search method, which is a technique that allow you to find the best version of your model by finding the optimal parameters leading to the best score of performance. So if you're doing regression, you will find optimal hyperparameters to find the best R square. And if you are doing classification, you will find the best hyperparameters for the highest accuracy. And moreover, I am going to utilize these two techniques for the existing algorithm, which I have already recorded this session during my SVM class. Okay, so if you have not watched that SVM session, please do go and watch that prior this lecture. Okay, so what I'm going to do here is I'm going to apply KFold cross validation and grid search method just to estimate the best model and the best parameters, right? So let me give you a small introduction to the dataset. Okay, so the dataset what we are using is social network ads, in which we have two independent variables, those are age and estimated salary, and one dependent variable vector, purchased column. Okay, so the main vision of this model is to estimate and predict whether a given customer, by the age and given estimation of the salary, whether he or she is going to purchase a new brand car from that organization or not. Now to predict that, we had already written the algorithm, and of course we had developed that deployed the model using the algorithm kernel SVM. Now to get more information about it, we are going to apply KFold cross validation. Also we are going to apply grid search method to find the best model and the best parameters. Okay, so let us start with that. So before that, let me just give you a small information related to all the instructions which are written to build the model. Okay, first of all we have to import the libraries. We had imported only one library as such, that is pandas, and we have to import the dataset, right? And of course we have to split the dataset into two matrix of features, x and y here. Okay, let me execute these lines of code here, and you can see that we are successfully able to upload all the data, and this is the data frame what we have. And of course we will be able to see three variables, age, estimated salary and purchased, and we are able to derive matrix of feature x and the dependent variable vector y from the data set. Okay, and of course x will contain only the first two columns, those are the age and estimated salary, and y will contain the last column, that is the purchased column. Okay, after that we have to split the data set into training and testing. We have taken 25% of the data for testing and rest 75% for the training. Okay, let us execute these lines of code, and now let us observe the data set. Do we require any feature scaling mechanism here? So we have X train here, and of course you can see the data are not in the right scale. Okay, to bring these data into the right scale, we have to apply feature scaling mechanism, and we have two types of techniques which can be applied here. One is standardization and normalization. For this case study we are going to apply standardization. Okay, and we are going to apply it to the trained and test data set, and after that the kernel SVM model was trained on the trained data set. So we had imported SVC class from the SVM module, and we had used the kernel as RBF, radial basis function, with the random state is equal to 0. Okay, So when we put random state equals 0, it is going to take the same test set, okay, and it is going to give you only one result, right? So now what happens if I execute these lines of code, you will be able to build your model, okay. Later on we had estimated our model performance by the two performance metrics, confusion matrix and accuracy score. And of course, after I execute these lines of code, you can see that the confusion matrix and the accuracy of the model has been displayed here. You can see 64 plus 29 right answers and 4 plus 3 7 wrong answers we have got, okay, out of 100, and the 93% was the accuracy of the model. And this accuracy 93% we had tested only for one set of data, one set of test results. Since we are given random state equals 0, it will validate only for the one set of test results. Now to just to ensure that we can get many results from the many folds of the test results, so we have to apply this K-fold cross validation technique, okay. As you understood that K-fold cross validation consists of creating a certain number of train test folds. Let's say in our case we had given 10 train test folds, because 10 is the commonly chosen value here. So it consists of 10 train test folds on which you are going to train your machine learning model on each of the train folds, okay, and at the same time test it separately on the test folds. And therefore, since you have 10 train test folds, well, you will end up with the 10 different accuracies on different test sets, right? And therefore this is a much relevant way to measure the performance of your model, because you know that this will make sure that we don't get lucky on one single test set. So if you put random state equal to 0, you will get only one single test set results, okay. So to avoid that confusions, we are going to apply this K-fold cross validation, and let us see whether we are going to what kind of accuracy we are going to get for each and every single fold of test set results, right? So here we are creating 10 different test folds to evaluate the model on different test sets, and therefore we are using any risk of getting lucky on separate test sets, right? And finally accuracy, what we get is the average of the 10 accuracies obtained with the 10 test folds, right? So based on this we are importing this cross underscore val underscore score from the module model selection, okay. After that we have to create an object called accuracies, which is going to hold 10 accuracy, okay. This is just like a list which is going to hold the accuracies of 10 cross-fold validations. Now we are going to create an instance of the class, and the estimator, what we are giving it as a classifier, okay. What is the classifier we had used here? Kernel SVM, right? So this is the estimator, and of course we have to give the matrix of feature x, that is x train, and y train, okay. And the number of folds what we are giving for this is 10 folds, okay, 10 cross-fold validation. And of course, to present it in a better way, we are using this print statement here. So we can see this is a float with the 2 decimal values, and we have to format it to calculate the mean of it, okay. So this will compute the mean of the 10 accuracies within that list. So accuracy dot mean, and to get it in terms of percentage, we have to multiply it with the 100. Similarly, we are going to apply the standard deviation here, right? So, because since we are getting 10 different accuracies, it will be very interesting to see what variance we have among the accuracies. To estimate the variance in the accuracies, we are going to apply the method called a standard deviation. The same thing we are going to, from these accuracies, we are going to invoke a method called standard deviation, that is STD, and to bring it in terms of percentage, we are multiplying it by 100, okay. So let's execute these lines of code, and we can see that this is the average accuracy after tested for 10 cross-fold validation for 10 different test set results. We have got different accuracies. So average of all that accuracies, what we got as 90.33%, okay. And the variations what we can see in the accuracies is 6.57%, okay. That is the information what we are going to get after we apply K-fold cross validation, right? Now we are going to move on to the next concept to learn the technique that can find the optimal values of your hyperparameters in your model. Okay, so let me let you know why we are taken kernel SVM here. So indeed the kernel SVM model has lot of hyperparameters, right? And these hyperparameters are the parameters which are not learned during the training process. And these hyperparameters are many of them, like we have a C parameter here. Okay, we have C parameter, you can see it here, which is a regularization parameter that you can tune to actually improve the training performance by reducing the overfitting. Okay, so the default value is 1.0, but we will try by several values, like we have 0.25, 0.5, 0.75 and 1. So the lesser the value is the stronger relation it will have. Okay, so let us try with all these values, and we are going to utilize it for the kernel SVM, for the linear SVM classifier, and also we will try it with the non-linear SVM classifier, that is a kernel SVM classifier with the we have the kernel as a radial basis function. Also you can see the gamma value here. So this is the parameter you only enter when you choose either a RBF kernel or a polynomial kernel or a sigmoid kernel. Okay, so since we are using RBF kernel here, we like to tune the different values of gamma to actually find the best one, and we will try with all the gamma values here from 0.1 to 0.9 here, right? And finally we are going to create that instance of the class. This is the class we had imported from the model selection. So create an instance and store it in an object grid underscore search. Okay, the estimated what we are using is the classifier, and of course the parameter grid is nothing but the parameters what we are sending. This is the parameters, okay, for a classic SVM classifier and the kernel SVM classifier, right? Later on we are going to apply the scoring equal to accuracy. So scoring is the metrics, okay, with which you want to evaluate the performance of your model for each of these combination of hyperparameter values, right? So each of these hyperparameters values what you are given, you have to try to evaluate the performance of your model whenever for each and every hyperparameters you are going to utilize it here. Okay, and each of this combination of hyperparameters will be evaluated through K-fold cross validation. That's the reason I had given CV equal to 10. And you can see this finally a very optional parameter which you don't have to worry much about here. Okay, so this is a parameter that will set how to run your processes in your machine. So if I give n jobs equal to -1, which means that all your processes will be used to optimize the grid search process. Okay, so that's the reason I'd given n jobs equal to -1. And later on we have to fit this to the train data set, X train and Y train, and to once this all the multiple training is done, we will get all the final results, like all the accuracies resulting from all this combination of hyperparameters, and therefore after getting all these accuracies we will get the highest of them, and we will get set of parameters that lead to the highest accuracies. And to get the best accuracy and the best parameters, we have to invoke the method called a best underscore score underscore from the object grid search, and similarly we have to invoke a method best underscore params underscore from the grid search object. Okay, and finally you please print the statement here using the format specifier here for the 2 decimal values, and multiply the best accuracy with the 100 so that you can get the values in terms of percentage here. Now let's execute these lines of code here. It will take little bit of time because it has to check for each and every hyperparameters and estimate the best model and the best parameters. Okay, and now you can see it here. The best accuracy is 90.67%. Okay, it has taken after applying each and every hyperparameter for each and every test set results. Okay, and it has taken the average, and the best accuracy what it found was 90.67%, and the best parameter for C regularization parameter is 0.5. Okay, 0.5 for the this thing what the classic SVM classifier, and for the kernel SVM classifier the gamma was determined to be 0.6 with the radial basis function. So this is how one can try to estimate the performance of the model. So model selection will always try to give you the better solution, okay, because we are going to try the data set on different algorithms. So finally it should be clearly clarified that which is the best algorithm will suit for our case studies. At that time this KFold cross validation and grid search method will always try to help you and give you a better information related to these algorithms, right? So with this I would like to end this session. Thank you for watching this video. Please do subscribe the channel for more updates.